Alright, let's solve this truss with a method of joints. The objective of this analysis is to find the member forces for members GH, GC, and GB. We have a UDL load on the top of the truss, beams on top, and then the truss is simply supported, symmetric about members GH. Step 1 in method of joints is to find the global equilibrium. That means finding the reactions at the support A and support E. At E we have pin support, so we are going to have vertical reaction AY and then horizontal reaction AX. At E it's a roller support, so we will have a vertical support, so vertical reaction of EY. From the UDL or uniformly distributed load on top, we are going to have the externally applied point load at each joint. We can find these loads by using the tributary method. We have a tributary width of 6 feet for each point, so it's going to be 2.5 times 6, which is 15 kips at each joint. And for exterior point, it's going to be the tributary width is half of 6, that's 3 feet, so the loads will be 7.5 kips. Now if we apply equation of equilibrium, take a moment at point A equal to 0, considering counterclockwise positive, the equivalent point load for this whole uniformly distributed load is, let's idealize this as a simply supported beam A, E. We have a UDL of 2.5 kips per feet. The equivalent point load would be 2.5 times the overall span, which is 24 feet. So 24, this would be equal to 60 kips. So at point A, this load 60 kips is going to give clockwise moment, so negative 60 times the moment arm would be half of 24, and the vertical reaction at E will provide counterclockwise moment, so EY times moment arm is 24 feet equals 0. Solving this, we get EY equal to 30 kips, and summation of all the forces in vertical direction to be positive, assuming the upward direction positive, then AY plus EY and minus 60 kip, because 60 kips going downwards, equal to 0. So we just calculated EY to be 30 kips. That's why AY would be 30 kips as well. So once we find the global equilibrium or reactions at the support, the second step would be selecting a joint, drawing a free body diagram of that joint, and solving for the forces. So one thing you need to be careful when selecting a joint is each joint that you select should only have 2 unknown forces. For example, if we look at joint B, there are 1, 2, 3, 4 unknown member forces, but in truss, in every joint there's only 2 equations of equilibrium, so we cannot solve this joint B at this moment. But if we look at joint A, there's only 2 unknown force members, so 2 equilibrium equations, 2 unknowns, so we can easily solve for those forces, right? So let's start with joint A. Draw a free body diagram of joint A. That's joint A, and consider each member to be in tension first. So force in AF would be FAF, force in AB would be FAB, and then we calculated the vertical reaction at A. Now if we consider tension or if we consider any members in tension first, and if our assumption is incorrect, and if the member is in compression actually, then we will get the value of FAB to be negative. So, and another thing that's important to keep in mind is the arrow. If you notice the arrow, when I said tension, I pointed out the arrow away from joint. For example, if you imagine a rod or a member and it is being pulled outside, the tendency of it is to, you're trying to elongate this member, the tendency of this member is to pull itself away from this joint, right? Away from this joint. So anywhere you see the arrow away from joint, that means the member is in tension. Similarly, if there's a member and you're trying to compress this member, you're trying to shorten the member, the tendency of this member or the reaction of this member is to go towards the joint. So if there's joint, this member tries to go towards the joint. So any arrow that's away from joint is tension, and towards the joint is compression, right? Now once we have the free body diagram, we can solve for the unknown forces using the equation of equilibrium. Let's first see summation of all the summation of all the forces in x direction to be 0, considering the forces towards right positive. Here we don't have any external load applied besides FAB, so member force FAB is 0. Similarly, summation of all the forces in y direction to be 0, considering upward forces to be positive. Then we have member force FAF, plus we have the reaction 30 kips. Summation of these forces should be 0. That means our member force FAF is negative 30 kips. So our assumption that member AF is in tension is false. This is actually 30 kips in magnitude and is in compression. And what would be the arrow? Arrow would be towards the joint. Towards the joint. This is in compression with 30 kips. Right? Now let's move on to next joint. If we look at joint F, there are 3 members connected to that member joint F, but now since we calculated member AF, there's only 2 unknown members, FB and FG. So 2 unknown members, 2 unknown member forces, and then 2 equations of equilibrium. So we can solve this joint as well. So let's move on to joint F. Draw the free body diagram. There's joint F. Member AF, we just found out it's in compression with 30 kips, and there's an external load applied of 7.5 kips. Let's consider or assume FFG in tension, and then consider FFB in tension. Now we need to find the angle as well. We know that each span are 6 feet, 6 feet, 6 feet, and then we have the height 6 feet. So since these 2 angles are equal, sides are equal, the angles are going to be equal at the base. So 45, 45, this is 90. So this angle is actually 45 degrees, right? Now solving for the forces, 2 unknown forces. Let's look at summation of all the forces in y direction to be 0 first. So upward positive, then we have positive 30 kips acting upward, applied load of negative 7.5 kips because it's acting downward, and then the vertical component for this force FFB, which would be acting downwards, so negative F of FB cos 45 degrees. Summation of all these would be 0. Upon solving this, we get FFB to be equal to 31.82 kips. It's positive. We assume this is tension, so it is actually in tension. Right? Similarly, summation of forces in x direction to be 0, considering forces towards right to be positive. Then we have force in member FG, and horizontal component of this FFG acting towards right, so positive FFB of sine 45 degrees. summation would be 0. We just found out FFB to be 31.82 kips, so member force FG would be negative 22.5 kips. So negative indicates that our assumption is wrong. This member is actually 22.5 kips in compression. So let's draw that here as well. FB is in tension, that means away from joint, right? And the value is 31.82 kips in tension. And then we found out FG, which is compression again towards the joint, right? The value of FG is 22.5 kips in compression. Now moving on, let's look at joint B now. We know that FAB is a zero force member. We know we calculated the member force FB, right? So the only unknown forces are member FGB and then BC. So let's look at joint B. Draw the free body diagram. B, FAB is 0. This is 0. And we have considered FBC to be tension. We calculated FFB. Calculate FFB, which is equal to 31.82 kips. And the angle is 45 degrees. And then we have one more unknown member force here. Let's consider this tension FBG. Again, apply equations of equilibrium. Summation of forces in y direction to be 0, considering upward force to be positive. We get what? Positive FBG, right? And the vertical component of FFB, which is 31.82 kips, so plus 31.82 kips times sine 45 degrees. So these forces would be 0. Calculating, we get FBG to be negative 22.5 kips. Again, we assume this to be tension, but this is actually 22.5 kips in compression. And summation of forces in x direction to be 0, considering towards right positive. We have member BC and the vertical component, horizontal component of FFB, that is minus 31.82 cosine of 45 degrees. Summation of all these forces 0. Calculating, we get FBC equal to 22.5 kips, which is actually in tension. So drawing this here, we have FBG compression, so towards the joint, and this is 22.5 kips compression. FAB is 0, FBC is in tension, so away from joint, and the value is 22.5 kips in tension. Now let's look at joint G. Joint G, there is external applied load of 15 kips, and we have FG, GB, GC, and GH. So we have a compressive load of 22.5 kips, and then we have a compressive load from here, 22.5 kips. this is unknown. Let's consider this as a tensile GC, and then this is unknown. Let's consider this as tensile GH. Again, solving using the equation of equilibrium. Well, actually, if we see here summation of all the forces in x direction, there are two unknown forces due to the horizontal component of this and then FGS. So it will be impossible to solve this equation first. So let's look at summation of forces in vertical direction to be 0, all the upward direction positive. Then we have 22.5 kips and 15 kips downwards, and then the vertical component of FGC, which is FGC sine 45 degrees. Summation of all these forces would be 0. On solving, we get FGC equal to 10.61 kips in tension. So now once we know FGC, we can apply summation of forces in x direction to be 0, considering forces towards right positive. Then we have FGH plus we have 22.5 kips towards right, and then the horizontal component of FGC cos 45. Summation of all these forces would be 0, right? We calculated FGC to be 10.61 kips. Therefore, FGH would be 30 kips. It will be negative. These two terms goes on the right side of the equilibrium. So negative 30 kips. This means that member GH is 30 kips in compression. So GH in compression, that's towards the joint again, 30 kips compression, and then GC is in tension, which we found out 10.61. so away from joint, 10.61 kips in tension. So this is how we find the member forces using method of joints in truss.